This is Algebra 2 with Trig, 8C.2. We're working with Law of Cosines. What we've learned in the past is that Law of Sines we used when we had information about triangles for angle, side, angle, 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 side, and side, side, angle. When our information falls underneath this category, and this category always gives us, we need to know the angle and its corresponding opposite side. That's what you need for Law of Sines. You need to know the angle and its corresponding opposite side. If you have that, then you can use Law of Sines. These are the two cases where that doesn't happen. If you're given side, angle, side, you don't have the angle and its opposite side. If you're given side, 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 you definitely don't have any angles. You don't have the angle and its corresponding opposite side. So we have to use a different method. And that's where this law of cosine comes into play. So we look at the pattern of these formulas for law of cosines. There are three formulas, just like there were the three ratios for law of sines. We have one that's working with A, which happens to be A squared, one that's working with B, so we have B squared, one that's working with C, so we have C squared. Look at the pattern. It's very much like Pythagorean theorem. Here we have an A that's being squared, and it equals B squared plus C squared, minus those same two letters, times the cosine of A. This is B squared, that equals A squared plus C squared, different letters than the B squared, minus 2 times those two letters, AC, cosine of your B. So what is this formula going to be? If this is C squared, what should this one be? That would be A squared, B squared, minus 2 times AB cosine of C. So those are your equations that you would be able to use for law of cosines. So we have some situations, and we'll discuss them as we go. There are some special rules to keep in mind if you use law of sines. We're going to use law of cosines to find one value. Then people typically swing over and use law of sines to find the rest, because law of sines is typically a little smoother. They're proportions. You cross multiply. People like to use law of sines. But law of sines has its limitations. If you have side, angle, side, and your angle is acute, after finding the last side, we have to use the smaller side to find the smaller angle. Then you can subtract to help you find the largest angle. You cannot use law of sines to find an obtuse angle. Law of sines will not calculate an obtuse angle. That is a big deal. So you have to know, when might that angle be obtuse? And if it could possibly be obtuse, don't use law of sines to find it. You should subtract to get it, or you should use law of cosines to get it. Because cosine, remember our unit circle, and when we were doing inverses, sine use those two quadrants. That means sine does not use the second quadrant. Sine does not give obtuse answers. Where cosine used these two quadrants, meaning that cosine would find an obtuse angle. So we can use cosine to calculate an obtuse angle, but you cannot use sine to calculate an obtuse angle. If our given information is SSS, given all the side informations, then we have to find the largest angle first. And you know that it's the largest angle first because it's opposite from the longest side. Use your law of cosines to find the largest angle, then it doesn't matter how you do it after that. You can use law of sines just fine because you can't have two obtuse angles in the same triangle. So let's start here with this one. We are given triangle ABC. So I would start by drawing out, since they're giving us an obtuse angle, let's draw that as obtuse. 108, that's angle C. They don't give me side C, so I don't have the one across from it. They give me side A and they give me side B. It doesn't matter which one you put where, but it would matter which one you label correctly. So A was 22, B was 15. So the angle has to be across from its side, and the angle is across from its side. So we've drawn our picture. So we see that we have side, angle, side. Don't get tricked up here and think that you have SSA. Just because they give you the information not in the order that it lies in the triangle doesn't mean that when you place it in the triangle you won't get it. So you got to use the triangle to help you determine what type of triangle you have. We have SAS. Need to use law of cosines. All right, we've got to use law of cosines because we don't have the angle and its corresponding opposite side. We cannot use Pythagorean theorem. We don't have a right triangle. You can't use Pythagorean theorem if you don't have a right triangle. So that's not an option either. So we're going to use cosine. What are we going to solve for? What can law of cosines clearly solve for in this case? If we were trying to find an angle and we were going to use law of cosines, if we were trying to find angle A, we would need to know what side C was. To find angle A, you need side C. To find angle B, you need side C. But to find side C, you need side A, you need side B, and you need angle C. So that's the only one we can solve for. Only thing we can solve for is side C in this case. So we're going to use the law of cosines. And it's important for you to know, hopefully you don't have to copy it forever, C squared equals A squared plus B squared, those two letters are different than the original, minus 2AB, those match these two, and cosine of C. So that's my formula for law of cosines. Now I can just plug in my numbers. I don't know what C is, but A is 22, B is 15, 2 times A times B times the cosine of 108. So I plugged in all my information. Now, there's a problem in here where people are going to make a mistake. it's dealing with this minus 2, 2215 cosine of 108. Some people are going to think that you're going to add this to the other side, or you combine all the numbers together, and you can't do that. This is a separate calculation compared to the 22 and the 15. So what we're going to do to help us stay out of any trouble is just plug it all in your calculator. Make it easy on yourself. 22 squared plus 15 squared minus 2 times 22 times 15 times the cosine of 108. And because we're using trigonometry and we're using angles, we need to be sure that we're in degree mode. So we hit enter, and that gives me what that whole calculation all put together is going to be. We could break it down individually. That would be great algebra skills. But there'll be enough algebra going on here that... Okay, so is my other side going to be 912? It can't be 900. 22 and 15 could only stretch out to be 37 in the best case scenario, or the worst case, the furthest case, is 37. 22 plus 15 is the longest, and that's actually too long already, that C can be. So 900 doesn't make any sense. But C squared is 900, that is correct. So I'm going to take the square root of both sides, and I'm expecting to get an answer smaller than 37. It helps to know what your answers can be. So we get 30.22. So C is going to equal 30.22. Now we have finally found another value that gives us 2 bits of information for the same letter, or it gives us the angle and its corresponding opposite side. So what can we do from here? We can now use law of sines. So we're going to solve for either one of our missing angles. It doesn't matter which one we solve for first. Because we're solving for an angle, I'm going to put the angle on top. So sine of A over its side, and I have to use my 2 bits of information, sine of 108 over 30.22. Now it would be wonderful if you use the answer button. Since the 30.22 is the last thing in your calculator, you can multiply these two and divide by the previous answer. That would be great. But you don't have to. We'll only be 0.01 apart at the very end. Well, okay. 22 times the sine of 108. You've got to close parentheses. Then you can divide by 30.22. And we get sine of A to equal 0.6924. I'm going to round it to 4 because my 5th number is 5 or larger, so that makes my 4th number go up 1. So we're going to do sine inverse of 0.6924. And that gives us a 43.82. That's my angle for the measurement of angle A. So A is 43.82. Now we need to find a third angle, the missing angle. So we're going to say 180 minus 108 minus 4382. So we take 180 minus 108 minus our previous answer, because that's just easier to type in, but you're welcome to type in 4382 if you like, and you'll get 28.18, and that's the measurement of angle B. So we have 28.18. There we go. All right. Let's jump down here. Let's see if we can jump through this one any quicker. We have angle B, that's 48. So side B would be across from it, but I don't have that number. So side A is 8, side C is 10. I don't know what their opposite angles are, but that would have to be angle A and that would have to be angle C. So since I'm given side angle side, I have to use law of cosines. And I'm going to solve for my B, so that's B squared equals A squared plus C squared minus 2AC cosine of B. I'm going to plug my values in. That's 8 squared, 10 squared. Okay, if you're at home, you can pause the video and see how your calculation comes out. This is a U-try. So we have 8 squared plus 10 squared minus 2 times 8 times 10 cosine of 48. And B, of course, cannot be any bigger than 18, so 56 doesn't make sense. I have to take the square root of both sides. So the square root of my answer is 7.55. So we found our opposite side. Now we're going to use law of sines to find an angle. Now we have to be careful here. This is what we've talked about before. We have the angle that's across from the smallest side. So this is definitely the smallest angle. The angle that is the largest is going to be across from the largest side. It's going to be angle C. So I'm not going to use law of sines to find the largest angle, because it won't give me an obtuse angle. If this happens to be obtuse, it wouldn't give it to me. So I'm going to solve for angle A. So that's sine of A over 8, and that is sine of 48 over 7.55. We cross multiply, and the sine of A, we have 8 times the sine of 48, and we divide that by 7.55, and we get 0.7874. So the inverse of that, now I'm going to use my answer button to pull down all the values into my inverse. Don't use the rounded numbers for that. And we get 51.95. That is the measurement of angle A. 51.95. So this adds up to more than 90, so this is going to be acute. So it didn't matter, but it could have mattered. So we'll take 180 minus our 48 minus our 51.95. Sometimes it's just easier to pull the previous number down rather than type it in. And we get 80.05, which is acute, so it wouldn't matter. This is the measurement of angle C. You want to label your work. So here's our last one. What do you notice that is different about this example? We have all the sides. We don't have any angles. So when you don't have any angles, you still have to use law of cosines. Now, law of cosines can find the obtuse angle, so we have to find the largest angle first. That's what those sentences in the beginning of our notes talked about. So we're going to find across from 31, since that's the longest side, angle C is going to be the biggest angle. So C squared equals A squared plus B squared minus 2AB cosine C. C is 31. A is 19, B is 26, and cosine of our angle, that's what we don't know. Now, you could take time and figure out what 31 squared is and what 19 squared is. That would be wonderful. But if we're going to use calculators anyway, we can just use 31 squared. I'm going to subtract my 19 squared, subtract my 26 squared. That's going to leave me negative 2 times 19, 26 cosine C. So I just go to my calculator and I type in 31 squared minus 19 squared minus 26 squared, and it'll take care of that whole process for us. That's negative 76 equals, and if we won't even make this problem. We're just going to keep it all separated. So what am I going to do to get my cosine by itself? You could multiply these together to divide, or you can just divide them. We can divide by negative 2 times 19 times 26. If you feel like you want to know what that number is, you could, but let's go to our calculator. We have negative 76 divided by. Now here's why finding that value might be helpful. You have to use parentheses, and you do negative 2 times 19 times 26. And I get 0.0769. That is the cosine of C. Because cosine of C is positive, that's telling us that our answer is going to be acute. If it was negative, that would tell us that we would have been in the second quadrant and our answer was obtuse. So it's possible to get a negative here. So we're going to do cosine inverse of 0.0769. That's the inverse of cosine. Don't make a mistake and hit sine. And that gives us 85.59. So we have 85.59 as our largest angle. That's the measure of angle C. Now we're going to use law of sines to solve for the missing other angle and then subtract to find the third angle. So to finish up this example, we're going to find an angle. We're going to use law of sines. Since we already found the largest angle, it doesn't matter what we find it with or which one we find next. So I'm going to do sine of B over B and sine of C, that's the only angle we know, over C. We cross multiply. Notice I have this angles on top because I'm solving for an angle. So I have 26 times the sine of 85.59, and I'm dividing that by 31. That gives me 0.8362. So sine inverse of 0.8362 is going to equal 56.74. Those are degrees, and that was the measurement of angle B. 56.74. And then to get the last angle, we can subtract. If you trust your numbers, you don't have to recalculate. It might actually benefit you to calculate it. Use a proportion, solve for A, and see if the angles get super close to 180. They should be exact, but if you're using any rounded numbers, they're only going to be very good approximations. 180 minus 85.59 minus 56.74. That gives me 37.67, and that's the measure of angle A. And our last one. The length of the side of a triangular plot of land. There's our triangular plot. We have 120, 150, and 175. We're going to find the largest angle. To find the largest angle, that has to be across from the largest side. That's the largest angle. That has to be found first. Just like up here, when you're given side, 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 you have to find the largest angle first. Law of cosines will do that for you. So 175 squared is going to equal the other two sides squared minus 2 times those sides times the cosine of our angle, and I'll just call it theta. So I'm going to take the 175 and subtract the 120 squared and the 150 squared. That's going to leave all this other on the other side. So we go to our calculator, 175 squared minus 120 squared minus 150 squared. We get this pretty big number. Now you could multiply this out and figure out what that value is, then divide it. Since you're using a calculator anyway, and you're showing some work, just divide by it. So that's going to cross these out, and you're left with cosine of theta. So over here, we're going to divide by parenthesis -2 times 120 times 150. That's giving us 0.1743. So cosine inverse of 0.1743 equals theta. Notice that this is a positive value. That means thinking about cosine. Cosine is positive in the first quadrant, so this is going to be an acute answer. If it's negative, that just tells us that it would be in the second quadrant, obtuse. So we're doing cosine inverse of our answer, and we have 79.96. That's our largest angle. Then you could use law of sines to find the other angles, but that's not what they're asking for here. They just want to find the largest angle. We are done.